All right, so this video is going to be for the last 3 lessons of Math Models Unit 4, and it deals with regression. Regression is something that we covered in the previous unit, but it does it a little bit differently here. So we're going to go through how to do these problems. I'll start with lesson 7, which is linear. In the description of the video, you will see links to each of the graphs that I'm using on Desmos. So look into the video description for those. So linear modeling is going to be taking data and it's going to be trying to find, again, that best fit line that we did in Unit 3. And so it's looking for the line that's closely going to relate those points, even if it's not exact. It's the one that gets the best explanation of that data. So first thing we're going to do is enter our data into the chart. Now, if there's a thing like a date or a year, you can just get rid of like the month, or if it's like 1901, the year 1901, you could just use 1 if you want. But we'll look at that here in a second. So we're going to use 3, 8, 13, 18, 23, and 28 for our x values. So going to this, when you open this graph, there's probably going to be data already here. But you're going to go here in X1 and you're going to enter those numbers: 3, 8, 13, 18, 23, 28. So those are my X values, and then my Y values are going to be these. Height of the grass, 1.2, 4.8, 6.2, 10.9, 12.4, 12.4, 15.2, I think was the last one. Yeah. So right away, the graph is going to look for the best fit line. And I made a mistake here. This should be 6.2 without a 2 there. There we go. So it's already found the line. It's the orange line. And you can see where our data points are. So it's pretty close to being through all the points. And so then all you have to do is your value. So let's go over here. The equation of the best fit line. So if we see the m is 0.55 and the b is negative 0.18. So we just need to look for these numbers here, the m and the b. We need to look for those numbers in our equation. So I see 0.56. That'll do. That's close enough. It's positive. And then we have minus 0.18. So that's going to be this guy g. That's going to be our answer. And then it says now predict the height of the grass on April 30th. So the easiest way to do that is really just to go over here onto the graph and just find 30. Look for 30 by clicking and dragging, and you're just going to kind of get as close as you can. So there's 30. There it is. I even got exactly 16.52. Okay, so the other way is for you to do this. X equals 30. And then it's going to tell you exactly where that intersection point is at 30. So on the 30th, we should have 16.52. So now theirs is a little different, but I would say the closest answer is going to be H. And the differences are coming from rounding. The fact that these numbers here are rounded, whereas this is more exact to more decimal places, that's why the different answers happen. So that's all you got to do for linear is you find that, and then you type that answer for the thing you're looking for, the 30 or whatever the new number is, and then you can graph the X line and find the intersection point. Or like I said, if I didn't have that line, I would just go here and I would kind of search until I found about 30, and that's what I would use. So that's how you do linear. I'm going to jump right over to quadratic. So quadratic modeling, again, I'll put another graph in the description of the video. I'm going to open it here. You'll get a link directly to this quadratic regression. Very similar. You're going to enter data here, and then it's going to give you the information for that one. I think I opened the wrong graph, so give me a second here. Yeah, I did. Sorry about that. 1 second. I'm going to fix before I send it to you, but let me just go in here and fix this graph. And it'll work for us. Okay. There we go. Yeah, I see there's an issue here. There we go. Okay, so now it's going to work for quadratic, and the link will work when you go look later. So we'll go to quadratic data, and then we're going to scroll down, and we're going to do the same thing. I'm going to enter the data into my table, like here, 9, 950, so on and so forth. So this goes up by 50 cents for each. So 9, 950, 10, 1050, 11, 1150, 12, 50, I think it goes to. Let's see. It stops at 12. So let's get rid of all this other stuff. There's a lot of extra data, and we don't need all of that. It stops at 12. So those are the ones we're going to have, and then we'll go put our value of our money, 468, 468, 479. Oops. Made a mistake there. 479, 487, 493, 496, 497, 495. So you can see it's found that that's what we're doing here. So they've got all the values. We've entered them in. And then we can see we have an A, a B, and a C value. A, B, and C value are going to be what we find here. So the A value was, let's see, -5. There it is, -5.05. B value is 115. There it is. And the C value was -158. So that's all coming from right here. Okay, so those are the three values. And then it wants to know 15. When it's 15, what is the answer? So I'm going to do what I did last time. I'm going to do x equals 15. And I'm